Hello, good evening, everyone. My name is Ronaldo, and today we're going to talk about proof by cases. Today we will explore a powerful proof technique called proof by cases. In this method, it allows you to break down a bigger problem into distinct scenarios and prove each case separately. This approach is particularly useful when a statement depends on multiple conditions and proving it directly is complex. By considering all possible cases, we ensure that no scenario is left unexamined, leading to a comprehensive proof. So on this slide, we're going to be talking about the definition of proof by cases, which is a mathematical method where we analyze different possible cases of a statement and prove that each case leads to the same conclusion. If all cases result in the statement being true, then we conclude that the statement is universally true. This method is particularly valuable in logic, combinations, and number theory. When to use proof by cases. We particularly use this when a problem naturally splits into different scenarios that we need individual verification. For example, when we work with integers, we often distinguish between even and odd numbers. This method is also useful when different inputs or conditions must be examined separately to establish it being true. Steps to set up proof by cases. The first step is to determine all the different scenarios under which the statement might hold. These cases should cover all possibilities without overlap or omission. Next, we tackle each case individually, showing that the statement holds true for that particular situation. Each proof should be logical, concise, and correctly justified. In each different case, it leads to the same conclusion. We can assert that the overall statement is true. For this particular slide, we're going to be giving an example of proof by cases. So we're going to go ahead and prove that x is an integer when x, parentheses x plus 1, is even, which is a mathematical example. We will prove that it is always even. So if x is even, we could express it as x equals 2k, where k is an integer. Substituting this into our expression, we get x, parentheses x plus 1 equals 2k, 2k plus 1. Since one factor, 2k is even, the product is even. Case 2 is x is odd. If x is odd, we express it as x equals 2k plus 1, where k is an integer. Then x parentheses x plus 1 equals 2k plus 1, parentheses 2k plus 2. Since 2k plus 2 is even, the product is even. The conclusion of these examples is it is an even product. We have successfully proven the statement on each case. So on this slide, we're going to explain how it is used to create a proof. Proof cases allow us to symmetrically examine multiple conditions in a structured way. We ensure that all the cases are covered is crucial for the method to be valid. This technique is widely applied in various mathematical fields, including number theory and logic. A well-structured proof by cases can simplify complex problems by breaking them into manageable parts.
In this slide, I will be showing you a second example of proof by cases. Here we'll be proving if x is greater than 1, or if x is less than negative 1, then the absolute value of x will be 1, or greater than 1. We'll start by defining the definition of absolute value, which is when it's greater than or equal to 0, it's equal to x, or when it is less than 0, it'll be equal to negative x. Now we need to separate this proof into cases in order to prove it. We'll start with case 1, where we will assume that x is a real number and that x is greater than 1. By definition of an absolute value, the absolute value of x will be equal to x. Therefore, for all values of x that is greater than 1, x will result in the absolute value of x being greater than 1. Now we can go on to the second case. We'll assume that x is still a real number and that x is less than negative 1. By definition of an absolute value, the absolute value will be equal to negative x. Therefore, for all values of x that is less than negative 1, the absolute value of x will result in being greater than 1. So in conclusion, we have x greater than 1, or x less than negative 1. Absolute value of x will be greater than 1.
The conclusion. Conclusion of proof by cases is a fundamental proof technique that ensures we account for all possibilities in a problem. By methodically dividing a problem into separate cases and proving each one, we establish the truth of a statement comprehensively. This method enhances our logic, reasoning skills, and helps us structure proofs effectively. I encourage you to practice this technique and apply it to more complex problems in mathematicals, and you'll see the results. Thank you for listening to us. This concludes our presentation.